thanks everyone for coming. This is our first ever Iterate webinar. So thank you everybody who is on today. This is going to be momentous. And thank you for everyone for coming. So first off, what I want to talk about is, what are we talking about today, first of all? So it's beyond SBOMs. And before we start to really get into it, I want to introduce my guests. So I'm going to start from the top of my participant list, which I have Aeva first. So Aeva, why don't you introduce yourself? Oh, and by the way, I'm Michael Chenetz. I forgot to say that.
Hi, Michael. I'm Aeva, pronouns they, them. Open source has kind of been my jam for a while. So I've been in this for a little over 20 years, starting out tinkering with protocols in the late 90s, and then MySQL, and then OpenStack and Kubernetes. And these days I'm on the OpenSSF Technical Advisory Committee and the board of the Open Source Initiative. Kind of had my fingers in a couple other places, co-started the OmniBor Project with Ed.
All right, Brandon, you are next on my list. Go ahead.
Awesome. Thanks, Michael. Hi, my name is Brandon. I'm part of the Google Open Source Security team, working a lot on supply chain, SBOMs, all that sorts, like everyone else here. My background comes a bit in kind of like the offensive security audit side, as well as more recently in open source security, involved pretty heavily in open source as well. And I'm a co-chair of the CNCF Tech Security. I also co-founded the Guac project with a couple collaborators with in Kusari as well as Purdue University.
Thanks so much. Cole, you're next on the list. Cole, we can't hear you.
Thanks for having me. My name's Cole Kennedy. I am a co-founder and CEO of a startup named TestifySec. We're really focused on supply chain security and helping organizations speed compliance of their software artifacts. I'm involved in a lot of open source projects. We have 2 open source projects, Witness and Archivista, that try to solve some of these problems. They're based upon the in-toto specification, and I am a member of the steering committee for the in-toto team, and I've also contributed to various CNCF projects. So thanks for having me. Should be a great discussion.
Yeah, thank you. All right, Dan.
Yeah, my name is Dan Lorenc. I'm a co-founder and CEO of a startup called Chainguard. Before that, I was at Google on the Google Open Source Security team, where Brandon is now. And I've been involved in cross paths with a bunch of folks here in different open source communities, things like the OpenSSF, the City Store project, a bunch of SBOM tangential efforts. One of the things we work on at my company is a Linux distribution called Wolfi, where we try to do SBOMs at every step of the way, and packages and all of that for containers. So I spent a long time building and reading and dealing with SBOMs.
All right, and last but definitely not least, Ed.
Hello, my name is Ed Warnicke. I'm a distinguished engineer at Cisco Systems. I'm sort of, interestingly enough, having the sins of your youth are always something you carry with you moment. In the mid-2000s, I built Cisco's industrialized SBOM facility, and we originally did it for licensure. We very quickly realized its value for what we called at the time third-party security. So a lot of mistakes were made in that process, a lot of lessons were learned, and some of those lessons flowed into the creation with Aeva of the OmniBor project, so that we can do it better this time.
All right, awesome, Ed. And by the way, who was it that said, was it Ben Franklin who said there that he figured out 2,000 ways not to do it, but you know, he only needed one way to do it right? Isn't that what he said?
I think it was Edison, but yes.
Was it Edison? All right, I wasn't sure if it was Edison or Franklin, so thank you for correcting that. But so out of everything that we learn, we also learn how to do it right. So I think that's the key message there. Yeah, so what I'd like to do first is really kind of frame up the discussion a little bit, kind of give a little bit of history of why this even became a thing. And really some of this is probably my opinion, and I'll let everybody kind of give their own opinion on it. But really, when you think about it, we started off early in the world of legacy kind of computing with libraries that lived on servers. Soon after when we connected to the internet, we had this kind of world of APIs where we started to consume these APIs into applications. And then we decided that we need APIs everywhere. So why don't we create these things called microservices where everything's just communicating over APIs? And at the same time, we went from strictly commercial, and in that commercial supply chain, a lot of times you have a lot more control over things. And we started to do a lot more in open source, which doesn't always denote, because I know I'm going to get some things from this panel here, doesn't always denote that there's security issues with that. But what that means is that there's more people touching it. There's more different things that, different elements that you have to consider. So it's different. So really, as we started to propagate and look at all this software or elements of software that go into these applications, all of this started to come about. So let me ask the kind of panel here: am I right in this? Is there more to it? What are you guys thinking about when you think about how this came about? Don't all answer at once. That's fine. I can just talk for a while too.
I'll bite.
Yeah, go ahead.
Right. So I agree kind of with the gist of what you're saying. The late 90s, a lot of companies were built on commercial proprietary software stacks. And the rule of thumb when I got into tech was you needed a couple $1 million in a couple of years to build a startup. And that couple million wasn't for your staff. That was for the hardware, the physical iron, and maybe a license from Oracle or Microsoft for a database and a web server. And then along came a couple open source projects that competed. And pretty soon you had the LAMP stack, Linux, Apache, MySQL, PHP, Perl, Python. And startups were popping up everywhere because it was easy to get off the ground. And pretty soon that became kind of the norm, where this free and open source software could just be taken off the shelf and used to bootstrap a new idea, a new company. We have two startup founders in the room here. You'll probably have an opinion on how easy it was to use that software to start. Fast forward 20 years and Log4j happened, or Log4Shell happened, where an open source component that is a tiny little building block used in almost every company, in a lot of commercial stacks, in hardware, everywhere, little logging library, and ended up having a vulnerability and affecting the world. So we went from everything's proprietary to, gosh, it's so easy to build a company and build a new product using this open source stuff, to open source is everywhere. Now we got to reconcile with that.
Yeah, Aeva, I think that's I'd like to expand on that, and the fact that we were all very concerned about delivering software faster, right? And everything that's been built over the past 2 decades have really been focused on DevOps, right? How can we deliver value to the customer faster? And we've done a really good job at that. You look at what GitLab's done, you look at what GitHub's done. All these great companies have really done a great job at this, right? But when you deliver these things faster, you're not doing the checks. We forgot to do the checks that we should do, right? If you look at system engineering, right, you have the system engineering V, and on the left side you have, okay, here's how it should happen, right? On the right side you have, here's how it did happen, and they should match up, and we forgot to do that. So yes, we can deliver software faster, but we're not doing it securely.
I also think that this kind of has snowballed throughout the years, right? Like you said, it started getting easier for people to do things, and then those folks didn't quite do the necessary checks. And we've accumulated the years and years of abstraction, and now when you import a library, you're importing like maybe as big the amount of code that would have been like 20 years ago.
Yeah, and I want to go back to Aeva's point, because I think it was great and touched on some of the issue here. Open source has delivered an immense amount of value to the world, right? People are building trustworthy systems on it. Open source provides a great, secure starting point. There's tech debt in open source. There's tech debt in all software. It's impossible to measure. But I think the risk posed by open source isn't one of open source insecurity. It's more of a concentration risk. That's kind of what happened with Log4Shell. It wasn't that there was a vulnerability in source code. There's vulnerabilities in all source code, all software everyone writes. And the problem isn't that folks are using Log4Shell. The problem is that the industry is using the same open source, and that provides a risk. It would be the same as if it were proprietary software, but open source outcompeted and is now the one doing this. You can't really have a market-driven solution to this when everybody in the world is using the same couple of critical libraries. That's where it does pose a national security risk. That's where regulators are stepping in. It's not because open source is insecure. It's because too many folks built on open source, and in particular, everyone is on the same stuff. A vulnerability won't affect a small segment of the industry.
Yeah. There's
the other, well, good.
Just a quick comment on what Dan's saying. There's an old saying, I think it's from the Cathedral and the Bazaar, that given enough eyeballs, all bugs are shallow. This is like the Old Testament to why is open source better? I think this decade, we need to reframe that as given a few eyeballs, any software contains vulnerabilities. We have more code than humans to audit and review it today. Sorry, Ed, go ahead.
That's okay. The other sort of flip side of what you were saying, Dan, about the concentration that we see in ecosystems around things like the fact that most of the world is using Log4j in the Java space, is the fact that the supply chains have gotten so long, deep, and complicated that most of the world isn't even aware that they're using Log4j. And so, you know, most people think in terms of, to sort of the point Brendan made, the thing they asked for, I want to import this library, I want to install this package. What they don't realize is purely in the open source ecosystem, there may be 15 steps back before you get to things. You know, you may have one thing in your Maven POM that pulls in, and 15 steps back is your Log4j. And this gets even worse when you see open source dipping in and out of commercial, where if you're a commercial provider and you get something from an OEM, and that OEM may be getting a little bit of open source and a little bit of stuff from, say, a chip vendor's SDK, and that SDK vendor is getting a little bit of open source and a little bit of stuff that they've licensed from somebody else who happened to have dipped in some open source. And the ability to see all the way down that chain is extremely challenging. And just the awareness that that chain exists.
Yeah, I think that was a big problem that we saw, especially, I mean, Log4j just illustrated that point perfectly, you know, because everybody was like, oh, well, I don't use Java, I'm fine. Yeah, no, not exactly. First of all, there's so many different wrappers around that, you know, that it's just like, it's really, really hard to kind of figure that out. And hence this whole, you know, kind of interest, and even the government interest in creating some kind of, you know, bill of material around software. So, you know, this is a good time to kind of talk a little bit about, first of all, maybe 2 seconds of what software bill of material is, but then we really want to go into very quickly, like more advanced, like, because when you talk about software bill of material, first of all, if you look at the NTIA, which is the National Telecommunications and Information Administration definition of SBOM, they require very, very little in order for minimal specs, and then kind of leave it open for analysis or for what you need. So really, the major things they ask for is author name, vendor name, version string, unique identifier, and then it says can include additional information. That's pretty I don't know, that just sounds really vague to me, you know, like, so that brings up a bunch of things like if you think about SBOM and you're talking about communicating this between organizations, between projects, between all these other things, if you just say additional information, how do you exchange that information? How do you figure out that it's the same information that you're exchanging? And how do you figure out that it's trustworthy? And I think that's, you know, let's talk a little bit about whether I've kind of captured this right. And then let's talk about, like, what are some of those things afterwards that we have to consider post SBOM?
Yeah, I'll start there. Yeah, the regulators that wrote this and the folks working on this initiative are walking this really, really, really tight line and trying to thread this really tight needle. Every field they add to that minimum requirements puts a lot of work on companies and vendors to add all of that stuff to their SBOMs. Every field they remove reduces the value of those SBOMs to the point where it might not be worth doing that work. And so it's this kind of like trying to find that optimum where the work required to produce all of that is justified by the value it captures. And yeah, to your point, right now it's a very low bar, and the exercise of having to produce these is kind of a kick in the pants to most of the industry today as they go try to untangle those dependency chains. It's like a step zero in actually, solving a lot of this. But getting folks talking about it, getting folks thinking about it, is a really good, step zero in the right direction, if you can even call it that. I think Ed had some great analogies the other day when we were prepping for this.
I think to Dan's point, it is a very fine line. I think, we're talking about this in terms of if you make it too easy, like you said, you're not getting any value out of it. But if you're making it too hard, what's going to end up is all the different agencies are going to then file exceptions, and then you're back to square one. But I think we're seeing a lot of information, but at the same time, because of this, we're seeing a lot of data, but very little data. Maybe a lot of data, but very little meaning. And what we're trying to do is kind of like figure out how do we piece these things together. There's a lot of need for having additional heuristics to figure out, oh, is this thing equivalent to this? And this is something that OmniBor is helping to do, to bring those identifiers together. And the project Guac, we're hoping to kind of be able to use these links to then be able to map into other information, take a SBOM that you have, augment it with what we have, and produce hopefully better quality data and insights.
Yeah, I'm going to give the NTIA a little bit of and CIS a little bit of slack here. The problem really wasn't very well defined when they started when Alan started this work years ago, right? And if they would have been strict on the definition of what an SBOM is, past those minimum elements, a lot of the innovation that we see in this space around SBOM would have been possible, right? So we have a lot of different opinions on what an SBOM should be. If you look at SPDX, if you look at Cyclone DX, right? There's different opinions. And while that's probably causing some issues in the short term, right? In the long term, I think it will be a better benefit that, those things weren't specifically defined exactly how they should be. Things will shake out. You can see that happening in these communities already. And we're figuring out solutions to these problems. But yeah, I think it's fair to say that, just an SBOM right now with the minimum elements isn't enough to say that this element or this artifact is secure or free of defects, right? You need a lot more information to do that. And that's where other specifications such as like in-toto come into play. And that's what we're working on. We have a new project that we're starting. I think we're looking at joining the OpenNet stuff, but it's called SBOM. And we're trying to figure out how we verify that an SBOM is accurate and trustworthy, right? And trying to figure out what the definition of that is. And if the NTIA would have done that years ago, if they would have made a bad choice, there would have been no SBOM for anybody because the adoption just wouldn't have been there.
So I think
it's important to note that the only difference between a good choice and a bad choice is about 3 years.
Yeah.
So
they could have made an excellent choice 3 years ago, and it would be terrible today.
Two really good points have been touched on by different folks so far that I want to highlight. One is the government's and NTIA, CISA's effort to get the industry to start generating these. That has precipitated a response. I think it was Dan who, I forget how Dan described it, but like, oh my gosh, what do we do? How do we do this? Everyone's scrambling to generate this information and make sure that it's accurate enough. And even though it's a really low bar, folks are scrambling to meet that low bar. It's a good thing they didn't make a mistake and set a bar too high and the wrong bar. On the other end of this, though, we have the incident responders. The next time something like Log4j happens, is this going to give us enough information to give incident responders enough information to figure out how to prioritize what systems to triage, what systems to shut down or patch first? And that's sort of the tension here, right?
That totally makes sense. I mean, a couple things I think of by what you guys are saying is, one is that these SBOMs have to be able to adapt to change. So whatever it is, it needs that level of kind of, I don't know if it's obfuscation, but some way to make sure that it can adapt to 3 years from now. So whatever those standards are, make them adaptive. The other thing I think of too, though, when I think about this is, whose job is it to provide information that goes into the SBOM? Like, is it everybody's job to create a certain subset of information? Or like, is it, maybe GitHub or GitLab has a certain responsibility. Maybe the people creating software have a certain responsibility. Maybe, you know, and all of that kind of goes into it. But then I think about like the standard interchange. How do we exchange that information and how do we agree upon it? That seems to be the most difficult in my mind.
It turns out, oddly enough, the only entity in the entire system that actually knows what got built is the tool that built it, right? That's the only thing that actually knows what the inputs are. And so at the end of the day, I think you have to say that the responsibility for really figuring out what's happening basically lies either with those particular build tools or with things closely observing them. So that you can actually know what got built into every particular thing. And this is part of what OmniBor is focusing on, is distinctly identifying with canonical, immutable, unique identifiers that we can all agree on, the inputs and the outputs, so that we can then associate to them the kinds of metadata that becomes useful for humans. And it turns out things like the package name, the version, the author, all those things that are part of the requirements, they actually turn out to be metadata. And you have to sort of be deep in the problem to understand that. Like, how many folks have seen someone pick up a file or a small cluster of files from one code base and drop it in another? Quick show of hands, right? We've all seen that happen. But now what you actually have is a set of inputs that have been changed. Their package association may have been changed, but the CVEs are the same.
Yeah, and I like to model the supply chain as a series of transformations, right? And if we can record the transformations either through these system tools or maybe the kernel, right? We can identify what these we can backtrace what materials went into these transformations. And that's what we try to do with in-toto, right? We're trying to link the final artifact to all the processes that created them, and cryptographically link or trust all these different objects and be able to link them together. And that gives you a full view of what happened in the supply chain beyond just the SBOM, right? Because the SBOM is just talking about materials. We're not even talking about process, which if you look at documents like SSDF or Salsa, right? Only a small part of that is actually about the materials that went into that final product. Much of that is really about the process that goes in the decisions and tracking those decisions, the testing that goes into it, et cetera, right? None of that is captured at all in the BOM. So being able to link all those together to that final artifact is extremely important to understanding the full security vulnerabilities associated or the compliance status of that artifact.
And to add on, I think, you know, we have the builders and getting that build provenance in to ensure that we are able to determine some trust for the kind of list of ingredients we have. But at the same time, you know, it's all fun and games until, you know, oh, a builder gets compromised, and then, you know, which SBOMs do we not trust anymore? And if we are making security decisions based on this metadata, we need to treat the metadata with the same level of assurance and security confidence as we do the artifacts themselves. And I think this is where the problem becomes a little bit more complicated, when now you have organizations, you have people, you have, you know, all these entities that are now introduced into the system, and that's where it gets really tricky to bring everything together.
Yeah, multi-party trust on top of all that is just a complex issue.
And it gets even more complicated to think about the constraints on open source communities and projects and independent developers as distinct from the constraints on companies. Right? Companies have money and no time. They're all in a competition with each other. And communities typically have time but no money. And so you can't ask them to install a piece of software that's going to cost them money to run to generate these attestations. And if you're asking a group of, you know, hobbyists in what's the XKCD, it's like what one developer in Tennessee maintains a little tiny block. That person is probably not going to go set up a whole in-toto thing to observe what they're doing on their laptop. but just because you want it, right? So how do we balance these different constraints on communities versus companies? Still not sure.
Yeah, I think, just to go back to that, one of the things that always concerns me is what effect does it have on a pipeline? Because really that is the differentiator between people consuming it and people not consuming it. I've seen so many products that are great or solutions that are great, but then you have to directly modify your pipeline, which takes time, and people are like, I'm out. So really, you either have to build it into the solutions, or you have to make it so easy that it's like one extra step in your pipeline. Yeah.
Ideally zero.
Ideally zero. Yeah. Building it in is the way to go. So things should start to create this. But then interchange still becomes a problem. Interchange between organizations, between projects, that to me is more complex. Well, maybe it's not, because I could ask Ed. Ed will probably argue that, and Aeva, that it's probably with OmniBor, it's equally as hard to figure out like what this should look like. But I think an equal problem is how do you exchange that information and trust that information afterwards?
Well, and how do you knit it together? I mean, if only there was someone working on a project to allow you to easily knit together all the pieces of data wherever they may be.
If only someone else was working on something to make it easy to sign and know that, what you have in your hand is authentic.
Which brings me to a point. Is this going to be like, we as a group of people right now have to bring this together so that it's not a million different projects and everybody has to consume these different things, because otherwise then we start to fall into the good and bad problem we have with like cloud native, stuff from the foundation, is that, hey, there's a million projects you can use. That's great. But you know what's not great? You have to figure out how to stitch together these million projects that you have to use. So we need to figure out how to simplify this, because this is a security issue, which is something that's much more critical than other aspects. So is it let me bring this back. Is it our job to figure out how to make it easy, or is it our job just to create the components?
I think that's been the problem with this all along. If you look at in-toto, the reason why we haven't had adoption of in-toto is just because of the complexity of implementing it, right? In-toto solves a lot of these problems when you look at that paper. But have you ever tried to create an in-toto policy? Raise your hand if you have. I mean, it's really difficult, right? And even just creating that in-toto attestation data can be difficult as well. So a big factor of adoption is going to be that user experience. And, that's why I'm happy to see there's some commercialization happening here, because that's what we're driving to do, right? Is we're trying to drive down that cost to implement this stuff, so we can get users onboarded quickly. So I think this is really good. The direction we're going, we needed to solve some of these problems first and figure out some of the APIs and actually the technical stuff behind it. And now we can start working on driving down that implementation cost and improving the user experience around implementing these solutions. Dan's done a great job with Cosign and this whole SigSort team. How easy it is to sign something with Cosign now versus signing something 10 years ago, right? So innovations like that are going to continue to happen, and and driving down that cost will increase adoption over time.
Yeah, I think just trying to like make it easy for folks. I think that's kind of partially, I think what one of our aims is with Guac is kind of like, I don't want you to worry about formats. I don't want to worry about SPDX. It's like on DX. And then even within like, now we have in-toto attestation for Salsa. There's new standards like the size standard for vulnerability reports and things like that. So many new things are going to come out. Providing this layer of abstraction, a way to be like, don't worry, like all you need to know is like, here are the policies you want to enforce. Here are kind of like all the information that's distilled for you. And hopefully that will provide kind of a more consistent experience, hopefully for consumers.
So backing up a little bit, what's involved in attestation? Because I know that's one of the big things that we're considering, as one of the elements, so maybe for everybody listening, what's involved in that?
Which kind first? Crypto?
Yeah, what is an attestation?
Attestation has so many different definitions.
Term for sure.
What do you mean?
Yeah, no, because I think that, like OmniBor solves some problems where you are figuring out
But it
what
provides
it's
a,
built with,
So
but then
a bill of
on top of
receipts,
that,
not an attest.
no, but let me finish. So sorry. Once you have that, then I know that there was some talk about, and I'm not sure if this was part of OmniBor, so I could be mistaken, but there were some thoughts about looking at, okay, how it's built here. Is it built the same way at 3 different companies? And if so, build a better trust score, so that's the kind of stuff
Yeah,
I'm
so
talking about.
I think part of what you're getting to, and this is where I think ease of use in this space is going to come through the emergence of facades. And I suspect the stuff that Brandon's doing with Guac is going to be a significant player in that. Because one of the really nice things about supply chain security is it's mostly a modular space. Like OmniBor doesn't have to talk about how you're going to sign an artifact dependency graph because there are other people who sign things just fine, like Sigstore. When someone says, okay, well, how are we going to attest this? And the answer is, well, we have these wonderful in-toto people, and they've got this great tool, Witness, that already gives you enough attestation to run through and be able to get where you want to go, right? And so there are lots of pieces and parts that are being done in proper modular fashion, but we've already got things coming together to sort of put a facade on top of them that makes them easy to sort of look at and consume.
I'd like to back up a second too and
Yeah.
talk about what an attestation is, because most organizations already are completing attestations, right? It's just sitting in an Excel document or a Word document, right? And they're already discussing what they're doing in their supply chain, but it's in a very manual, right? So these documents then go up to some compliance officer, and then you got another person that looked at these documents, compares the SHA-SUM of this artifact, and says, okay, yeah, this can go into production, right? Carry that across the air gap into the secured environment. What we're doing in in-toto is trying to standardize that whole process so we can automate it, right? We're standardizing how we sign these attestations. We're standardizing the schema of the claims in the attestation. And when you do that, it gives you a really powerful construct and you're able to create policy over that. So all this data that was previously living in an Excel document or in a logging platform and all these other places, well, now because we've all standardized it in an in-toto attestation, we've all signed it in a DISI envelope the same way, right? So now all these different systems can all talk to each other. And if we understand the schemas per attestation, we can create a policy, right? We just have to evaluate a JSON and see if it matches what we expect it to. If it does, give it a thumbs up. If it doesn't, give it a thumbs down, right? So when we have an attestation, it creates, we already have the attestation. What we're trying to do in Toto is to create a framework to automate the whole process and standardize these attestation types.
Sorry, I was on mute there. No, that makes total sense. So it's going back a little bit because I'm just looking at some of the questions here. One of the real questions was, well, where do we start? Where does somebody start that gets into this? So what do you recommend for someone that wants to, and I guess that's kind of a rough question because you really don't, what do you start as what? As a coder, as a as a company, as a, so actually we probably need a little bit more information, but I don't know. Any comments on that?
And I think the next comment in the chat there was combining modular open source components is typically the domain of commercial products. I agree with that. And also, we need to make this the default out-of-the-box experience for open source projects or for the output of open source projects so that when folks, individuals, research teams, universities, companies, governments, whomever, are picking up an open source project off of their favorite repository, PyPy or NPM or Docker Hub, whatever it is, it comes with enough information in the supply chain, the attestations, the signatures, all of that, that they can verify it. And so on the consumer side of open source, that's my lens, I know it's not everybody's, but on the consuming side of open source, where does someone get started? Well, we need to have enough consistency in covering all the right elements so that folks who are downloading open source 3 years from now, it's just there. It's part of the tools for them. It's part of the user experience when you go to NPM or Docker Hub that it just shows you, here's the signature, click to verify. Like we have in browsers now, the little lock icon, you can hover over it and see, oh yeah, that's signed. I can trust this website, probably.
I think in order to get the information and attestations, Ava, you're talking about, this has to start. It's kind of everyone's responsibility here. We talk about, enabling checks, auditing the dependencies, and then providing attestations yourself, providing SBOMs for the libraries and the applications you create, as well as, recently we talked a lot about vulnerability exploitability exchange, or VEX, to say that new vulnerability has come out. I'm using a dependency. I'm the only person. Well, I'm one of the few people that are knowledgeable enough in my code base to determine whether I'm affected, and that is, we've seen a lot of open source developers struggle with that, because you're like, I'm using this dependency, it has a vulnerability, but it's like 5 libraries down the chain, and I have no way, like, I'm not going to be able to analyze all the way down and determine that for myself.
Interesting. So I think almost what you'll see, just by what, and correct me from what you're describing here, is that almost at every level there will be some kind of check. And so as you're consuming an API, there might be a check. As you're consuming a library, there might be a check. As you're consuming and really it'll be more iterative along that chain, in order to see that everything along that along there is as it should be.
In some sense, this is why it has to be different this time, right? Because supply chain security is something that has to happen. It's intractable at the end, like literally intractable. So it has to be addressable easily along the linkages through the system. Because if you say, okay, well, I'm going to go and stitch together a commercial product that does the things you really need to actually take advantage of it, you're at the end. The people who are paying you money are 15 steps deep in that supply chain, and the component that is 5 steps deep in that supply chain is really where the fix has to go in, and it's mandatory. That's what has to happen. So I don't think you're going to see the split here where the full solution is a commercial product from the point of view of developers. You may see it from the point of view of managing fleets of things, where I'm an entire IT shop and I've got to manage thousands of applications that are deployed in dozens of environments. Like, I think that will probably be commercial. But I'm a developer who's consuming something, that can't be a commercial product, because it makes it impossible to solve the real problem.
Yeah, we've danced around this a little bit now, but I think it's time we just jump in and keep talking about commercial products. And there's a difference between the technical solutions and then the legal ones, and there's a whole can of worms being opened right now with like stuff like the self-attestation framework, the complete different type of attestation now. This is the kind where you sign it on a piece of paper with a pen. Framework in the US that says commercial vendors are now responsible for all of the open source they ship. That should have been the case forever, but this says it in plain text right there on page 1. And as well as the Cyber Resiliency Act going on in the EU, which comes at this from a very different perspective and is confused in a lot of ways. But yeah, it has to be different this time, because laws are coming, regulations are coming, and it could either have a good effect or a completely confused wrong one, depending on which way we go here.
Yeah, and the government's not going to be the one who enforces those self-attestation forms, right? It's going to be the large integrators that bear a lot of that responsibility. So I'm really going to be interested to see how they are enforcing some of these things. If you've ever worked with a large integrator, right, you've gone through mountains of paperwork to try to, get it on an MSA or try to sell your products to them, right? Because they carry all the legal risk and burden. The U.S. government isn't going to sue little TestifySec if we give them vulnerable software. Right, but they are going to sue the integrator that we work with if we do that, right? So I see. This is going to be a multi-year process, but it's going to be interesting to see how it all plays out, and where the liability hits and where these things are enforced.
Yeah, there's a chain of software being delivered and shipped and transformed, and then there's also a chain of liability that's following along. Yeah. It's mostly the same, but not quite the same, because it terminates in different places.
So this makes me think about, though, like let's take Log4j for example. We know, I'm using Log4j in there. We have 500 people, 1,000 people telling Log4j that, hey, there's a vulnerability. You have to update this vulnerability or fix it or patch it or whatever. First of all, where is the system in place to contact and notify these people that there are? Like, is there going to be a standardized system? This is more of a social kind of, or social or socio, whatever it is. And then what's their responsibility and time frame for having to do that? So I think there's like a lot of, you bring up a good point, like legal ramifications and also, physically, how do you do that? Is there a phone number? Is there going to be requirements? If you create a library, you have to do this. If you create a, how's that going to work?
There are two sides to that answer. And one is the social norm that every open source project has a maintainer, and it lists the maintainer's contact info.
Yep.
And it's been that way for decades. The flip side is every integrator, to Cole's point exactly, everyone who's integrating open source has and should bear the responsibility to verify that, in fact, they can do that. They can reach out if they have to.
Oh, man, that's such a high bar, though. I mean, most organizations, if running software in production, they can't even tell you who's responsible for their own software in their internal systems, right?
Yep.
So we have a lot of work to do to get there. And
Totally agree.
There's been so much neglect over the past couple of decades left to production and visibility in those systems. So yeah, it's tough. There's a lot of work, and I think it starts with visibility. We got to determine what we have and who's responsible for that.
But not just visibility, but also fidelity. Like one of the open source projects that I'm a maintainer on that has a bunch of downstream consumers, we get consistent reports of CVEs that people believe we have via scanners. And an enormous percentage of the reported CVEs that we receive from our downstream consumers that their scanners tell them we have are for components that we don't contain. And we still have to go through and make sure we haven't done something utterly bizarre like pull glibc into an Alpine container. But at some point, if you're an open source maintainer and you're strapped for time and energy and you're drowning in false reports, you're going to just turn off and stop listening. And so we have a really serious problem with the fidelity of our data that has got to be fixed.
The same is true if you are inundated with real reports, right? If you suddenly get 1,000 companies telling you, hey, there's a vulnerability, and you're like, dude, I know. The first person told me yesterday. Now my entire inbox is crushed by this and I can't get work done. Like, we have to solve that one too.
Yeah. It sounds like there needs to be better systems in place for this purpose. I think there's a technological solution and also a personal solution, so I think it's a combination of like, hey, there could be some great tech that you can create for it that could, like, if there's a vulnerability, press this button, and then we say we already know about this, do X, Y, and Z, and we estimate it'll be in this amount of time. And also there could be things that maybe auto solve these issues, so that you don't even have to do anything, that it's known, it finds out, it figures out, and it kind of auto remediates, so I think there's probably a lot of things that could be done there. Now, I know we're getting up it's about 1:45 my time, which is Eastern time. So I know we're getting towards the end of this. I wanted to kind of, maybe just get some final thoughts on this whole area. This is a tough one to wrap up. I know we could talk for hours on this.
Yeah, on this one area, I just want around this vulnerability stuff. It sounds simple, and in some ways it is. It's just strings and regular expressions all the way down in a database. But if you look at it the other way, it's one of the top 2 hardest problems in computer science. It's really about naming, which no one's ever going to agree on. So a lot of these false positives just come from people reusing names or not registering names somewhere, and name collisions and inconsistent naming schemes, and that's why the vulnerability database gets criticized so much. And there are some shortcomings there, but a lot of it is people just name things with the same common 4 patterns here and there, and they have no way to differentiate whether a vulnerability is in the npm events package or the 300 other different packages all named events or events util or something like that, because developers are known to be not that creative when naming packages. So there's a lot of cultural and kind of string matching related problems we're going to be dealing with forever.
And that's part of why when you look at things like OmniBor, we don't consider any of that to be validated identifiers, because they're not. because you want your valid identifiers to be something that's canonical, meaning that everyone independently agrees that this identifies that thing, everywhere, at all times, forever. And component name version supplier fails that test 100%. It's useful for people. It's super useful for people. You want that metadata, but it's not an identifier.
Yeah. So other last, I should say, other comments that we want to kind of leave people with, some thoughts that we want to leave people with in this, post SBOM world that we need to do a little bit more. Anything that you guys want to?
Yeah, I just like to highlight the point that the SBOM is only one part of the supply chain, right? We have a whole process that's involved, and in most environments, having a vulnerability doesn't matter as much as whether that code was actually signed off in the way that meets regulatory policy, or that that artifact wasn't built on a developer's machine, right? It was built on our secured infrastructure. So there's a lot of additional data that we need to collect to ensure that our artifacts are secure, that are potentially actually more important signals of security than just this vulnerability data. So please consider that and look at different frameworks such as in-toto to track that metadata and to verify it.
I think that having the metadata, everyone should be creating security metadata. And on top of that, I see that being a huge issue where we are getting a lot of information and security alerts. And usually, like we said, these things are not targeted towards folks that have the ability to respond to them, right? People always look at, we treat supply chain like it's a list of dependencies, but in actual fact, it is an entire graph. It is a supply chain, as you call it. And so I think we need to start treating it as the structure that it is, and hoping that Guac can try and solve that problem as well.
Aeva, Ed, any last remarks?
SBOMs are only the beginning; they're not the end. That's the one fundamental thing I personally want everyone to understand is they're necessary, but they're not sufficient. And if all you have in the world is SBOMs, you will not be secure. But you have to have them.
Yes, totally agree.
Certain patterns are emerging from this space. I think in the next 2 years, we'll be able to say with much more confidence what that looks like, both on the commercial side and on the open source community side. Totally agree with what others have said. SBOMs are the beginning of this. What I think we need, what I want to build is higher quality signal for incident responders. We're not going to have a world where there are no vulnerabilities. So we have to prepare for the world where our companies, our teams are managing huge fleets and think about vulnerabilities at a scale of molarity. How do we find them in the huge stack of software running in our systems, pull the actual things to the top of that efficiently to go address an issue?
Well, thank you so much, guys. And what I want to do is in 2 years from now, we're going to see if all this stuff comes true. So we'll verify where we are in 2 years from now, and we'll be like, oh, we thought all this was gonna happen. No, none of that really happened, or all of that really happened. So that would be really funny. But anyway, thank you again. I think this has been an amazing conversation. So you guys are amazing guests. I would love to have you on another time to really discuss this even more in depth. Thanks again.
Great.